Hi everyone. In this video we're going to actually work on the second question from the 2013 AP Calculus Free Response question, and this is a question that deals with a particle moving along a straight line but requiring speed. Keyword. The reason why it's a keyword, speed has certain characteristics and certain formulas which we have to work on, and we'll work on them on these 4 questions. Now, since this is a second question, that means that we're able to use a graphing calculator. And the reason why we want to use this is because we're not going to be able to actually solve anything by hand. All we need to do is plug things into a calculator, which we'll be able to do by the end of this question. So, reading this question, it says a particle moves along a straight line for a time between 0 to 5. The velocity of the particle is given by v of t, so this is my velocity equation, which is the derivative of my position. And the position of the particle is given by s of t. It is known that s of 0 equals 10. This is important, and I always recommend just circling it, because that lets you know that this is your initial. This is your starting point. You are starting at 10 when time equals 0. So when you read the question, it says find all values of t in the interval from 2 to 4 for which the speed of the particle is 2. Keyword is speed. When the speed of the particle is equal to 2. Thing is, if you don't know what speed is, there's no way you're going to be able to answer this question. Speed is found by taking the absolute value of your velocity. That's what speed's equal to. Well, they want to know when this equation is equal to 2. So then I'm just going to set it equal to 2. And this is for part A. So pretty much what's happening is I'm taking my equation that they gave me for velocity, which was -2 plus t squared plus 3t 6/5 minus t cubed absolute value, and set equal to 2. So what they're asking for is when is this equal to +2 and -2, because that's how absolute values work. So because of that, there's no way I'm going to be able to solve this. But what I could do is plug into my calculator. So if you have a calculator, just make sure you have it out so you can work with it. Since I'm actually working this out and I want to know when absolute value is equal to 2, I'm going to go to my y equals 2. I'm going to type in my first function. Now the problem is, a lot of times we don't know where the absolute value is. When you click on the math button, scroll 1 to the right. ABS is short for absolute value. Type in 1, you'll notice you have absolute value bars. Next thing is just type in the equation. -2 plus x. I don't really use, one thing you notice is I'll never use t, because t is the same thing as x. All we're doing is graphing it anyways. So you're going to put x squared plus 3x, close the parentheses, raised to 6 divided by 5, minus x cubed, and that's your equation. Then you want to find out when this is equal to, and on my next line I'm going to put 2. Then my next thing is just graph it, and then you should get something that looks like this. So I want to know when this graph is equal to 2. When do they coexist? Now you'll notice that it intersects here, 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 possibly here, maybe here. But you got to remember, they only asked us for 2 to 4. So we don't need anything before 2 or anything after 4. All we care about is what happens in the middle. So what I'm going to do is, because I can't really tell what happens, I'm going to zoom in by this button right there. Press 2 for zoom in. Now you'll notice that there's this little plus sign that you can move up, to the right, left, wherever. I want to see what happens between right there, because right there is from 2 to 4. So I'm going to go right in the center, press enter, and it's going to zoom in for me. Now because I'm trying to find out where it intersects, and I'll notice it intersects here as well as here, I'm going to go here, second then calculate, which is on top of trace. This button is used to find anything you need, from values, zeros, min, max, intersect, the derivative at a certain point, and the integral. All I care about is where they intersect. So I'm going to press 5. It's going to ask me for this first curve. Well, for the first curve, I'm going to scoot all the way over here. And I'm going to press enter. And you'll notice it's going to jump to my second curve, except I have to find where it's at. Over here, So then I'm going to go underneath it, because what I'm trying to do is I'm trying to calculate this zero right, I'm sorry, this intercept right here, so I want to get between it. Press enter, and it's always going to say guess. Just press enter whenever it says guess. It'll give you 3.12. That means that the first time that the particle between 2 to 4 is equal to 2 is at 3.127, and one thing you want to do when it comes to your AP exam, you want to at least round to 3 or 4 decimal places. But it's also equal to at another point right there. So I'm going to go back to second, then calculate, intersect, and then it's going to say first curve again. I'm just going to scoot to the right, press enter. My second curve, I'm going to go above it because I kind of want to trap it so that I can get the value in the middle of it. Press enter. Of course, it's going to say guess. Just press enter after it says guess, and it'll calculate 3.473. So your speed is equal to 2, not just at 3.127, but also 3.473. Those are the two values that your speed happens to be equal to 2. And that's what you have to do whenever they ask you a question like this. So then we can just move on to part B. Well, part B says this. Write an expression involving an integral that gives a position s of t. Well, you got to remember, when it deals with speed, a final position or any position is always s of t is equal to your initial condition plus 0 to some t of your velocity respect to t. That's your generic equation. Well, because they're asking me for an expression involving an integral that gives me the position s of t, I kind of know some of this stuff because s of 0 I already know is 10. So the answer they were looking for is s of t is equal to 10 plus 0 to t of velocity. So then my next step is, okay, use this expression to find the value of the position of the particle at time t equals 5. Well, that means that they're asking me for s of 5, and I'm just going to go ahead and plug it in. And all this is an integral equation, where v of t is equal to the position they gave, the equation they gave in the beginning. And guess what I'm going to do? I'm just going to come over here, and if you clear it out, it's going to take you to home page. Well, how do I solve these? I just have to plug it in. So when I plug in, I'm going to go to the math button again. Now when you go to the math button, if you scroll all the way down, you should see integral. Press 9, and it's going to set that up, and that's what you want. Now I'm going to clear it again because I thought there was a 10 in the front, so I'm going to put 10 plus math. 9 is the integral. You can just scroll down and type it in. 0, and all these boxes, just fill it in. 0 to 5 of the velocity equation. So then just type it in again. -2 plus parentheses x squared plus 3x, close the parentheses, raised 6 divided by 5 minus x cubed. And then the one thing you can't forget, you see how there's a D in a D box, respect to which letter? In this case, X. Press enter. And you get -9.207. And that's your answer. So whenever they ask you for a position, you have to remember, final position is the initial plus 0 to some time that they're looking for of velocity. And what's happening is it's calculating everything you need from 0 to 5, and then also adding where did you start from. I started at 10, and this is your answer. Okay? Then you get to part C. Well, part C is asking something different. Part C is asking find all times between 0 to 5 at which the particle changes direction. Well, you have to know, well, when a particle changes direction, that's like increasing to decreasing. Well, how do I find that? Well, in calculus, the only way we can find that are your critical numbers. is setting your derivative equal to 0. Pretty much v of t equal to 0. Well, that's just me setting this equal to 0 and then factoring it out, or finding x-intercepts. So you're going to come back to your graph, go to y equals 2. You already have the absolute value, so you already have it typed in, so you don't have to type it again. One thing you have to do is, there is absolute values, and you need to erase that. So you can just hover over it, and then press the clear button, and it's going to take everything away, but just then type everything back in. Negative t plus parentheses x squared plus 3x and then make sure you erase the 2, graph it. Now you are zoomed in, so what you're going to have to do is you're going to have to zoom out of it. So just click on the zoom button, press zoom out, and then just press enter, and it's going to zoom out for you. It's going to type or graph the function for you one more time. Now you got to remember, they're asking you for times between 0 to 5. So the only times I know are 0 to 5 are right here and right here. Well, I want to find where it's equal to 0. So that's, remember, second in calc, and it's going to tell you all these options. Because I care about zeros, the x-intercepts, I'm just going to press 2, and then they'll say left bound. Now, this is the thing that it requires practice. I know my first 0 occurs somewhere around there. When it asks for left bound, it wants you to move this little thing that's moving alongside the curve left of that 0, which is right there. Then it's going to say right bound. Right means go on the right side of this 0, which is somewhere here. It's going to say guess, just press enter, and you'll get your first 0 at time equals 0.536. But there's another one, because if you look at it, it occurs right there. So you're going to move second and calculate 0 left bound. Since we know it occurs right there, I just want to be left of it, which is anywhere here. So I'll just press enter. Then it's going to say right of it, which is somewhere on this side. So I'm going to go right of it, press enter, guess, press enter, and it'll calculate 3.317. Remember, round or at least have 3 decimal places. 3.317. These are my times for when it's equal to 0, when my velocity is equal to 0. Okay, now this is a part that's a little bit challenging. What I always do is I always put my critical numbers on the number line. First one's 0.536, next one is 3.317, and I'm going to cap it out at 5, and I'm going to cap it out at 0 because we're only looking for values from 0 to 0 to 5. Now if you look at your graph, this is velocity. Velocity is increasing, decreasing, because that's derivative. That's your first derivative. First derivative tells you your slope, increasing, decreasing. Anything above the x-axis when you're looking at a derivative is increasing. Anything below the x-axis is decreasing. So when you ask yourself what's happening from 0 to 0.536, you'll notice that your graph is on the bottom. That means that your graph is decreasing. Then you ask what's happening from 0.536 to that, 0.5 to 3.317, it's above, so it's increasing, because we're looking at the first derivative graph. And then 3.317 to 5 is below, so we know it's decreasing. Now there's a couple things that we just noticed about this graph. Right here is a minimum, right here is a maximum, but we don't care about that. What they're asking us for is, when does your graph change direction? Well, if you look at it, from 0 to 0.536, the graph is decreasing. From 0.536 to 3.317, the graph is increasing. And then just copy the left one down, 3.317 to 5, graph is decreasing. So because it went from decreasing to increasing to decreasing, the values of where it's changing position or changing direction from 0 to 5 0.536 and time equals to 3.317. And that's it for that answer. So then the last one. Is the speed of the particle increasing or decreasing at time t equals 4? Well, this is important because you have to know what's this increasing, decreasing when it deals with speed. This question is different than a velocity equation when it's just velocity. Is the velocity increasing or decreasing at time t equals 4? They're not asking for velocity, they're asking for speed. And when it deals with speed, in order for something to be increasing, either velocity and acceleration has to be greater than 0, or velocity and acceleration has to be less than 0. What that means is the signs have to be the same when you plug in 4 into both velocity and acceleration to be either greater than 0 or less than 0, meaning they're both positive, they're both negative, your final outcome, and that's going to mean increasing. Decreasing means that your signs are changing. So either velocity is greater than 0, acceleration is less than 0, or vice versa. But the signs have to be different in order for it to be decreasing. Now the next thing is, well, okay, that's simple. They want to know when t equals 4. So because of that, you're going to have to plug in 4 into velocity and acceleration. So I'm going to first plug in v of 4, but luckily I already know where v is. So technically you have to plug it all in, but remember you have your graph already. So then you can ask yourself, okay, at 4, what's happening at 4? Well, look, if I move this to the right, I'm going to get all my values for 4. So you see 4.04? Well, look at my value. It says it's negative. But I could also do this. Second in table, it's going to you can look at all your tables and you can plug in numbers. If you look at 4, you have negative 11.48. That's definitely below the graph, so you know that your answer is negative. So v of 4 is less than 0, but then you also have to find a of 4. Well, remember, acceleration is found by finding the derivative of velocity. But then I'm not going to go ahead and actually find the derivative of this. What I'm going to do is I'm going to go to my graph. Remember, second in calc, you see how it says dy over dx? That's at a specific value. I'm going to type in 6, and it's going to have x equals to 3. What you care about is this. Plugged in 4, press enter. It tells you that your derivative at 4 is negative 22.295. So that means that your acceleration at 4 was also less than 0. Whenever your acceleration and velocity are both the same sign, that means it's increasing. So then you just have to say the speed is increasing at time t equals 4 because velocity and acceleration have the same sign. So anytime they ask you if speed is increasing or decreasing, you have to find velocity, you have to find acceleration and plug the value in, and then if they're both the same, it's increasing. If they're different, then it's decreasing. Okay? So practice the problem. This is a long problem, but once you know the steps, there's no reason why you can get this wrong. Alright, thanks for watching.